In this video, we are going to look at the use of a Pythagorean identity, sine squared theta of cosine squared theta, and this equals 1. So again, let me write that identity, sine squared of theta plus cosine squared of theta, this equals 1. And again, the whole reason that this does equal 1 is if we go back to our unit circle, and we have the, some angle here, and then let's say we produce a triangle from that going down. This right here is still the radius of 1. This is x and this is y. So we would have, for Pythagorean's theorem, we'd have x squared plus y squared equals the hypotenuse squared, or 1 squared. Okay, in this case, x is sine, or in this case it's actually cosine. So this is cosine squared theta. Y is sine plus sine squared theta. And that in of itself is going to equal my hypotenuse, which is 1 squared, or 1. So we have this Pythagorean identity of sine squared theta, or sine squared x, it's going to show up in different ways, plus cosine squared theta equals 1. All right, let's hide this guy. I'm going to erase all my extra writing down here. All getting erased. So we're going to use this so that we can basically solve a problem. So what is sine of theta? So we're going to find sine of theta if cosine of theta equals -3/5. And what is the angle with measure theta in quadrant 3? So what is the angle? So here is the angle. I'm just going to use angle here. With measure theta is in quadrant 3. Quadrant 1, 2, 3. All right. So again, I'm going to get my unit circle guy here. It's kind of bisecting into there. And I am looking at this being in quadrant 3, not the exact triangle, but it's not. Let me draw that a little bit better for my angle here. Move that there, move it down here a little bit. There we go. I'm just going to go right there. All right. So we sketched the angle with a measurement theta and its reference triangle on the unit circle. So here's my angle. My reference triangle will then come up from this point. There's my reference triangle. And so the x is cosine of theta. The y is sine of theta. We talked about that just a moment ago. And so this point right here is going to be cosine . This would be sine of theta, sorry. Cosine of theta. The angle intersects with the unit circle. Yeah, no, see, they wrote it wrong in the book. Sorry, I did take a pause there because I was wondering why they put sine, cosine theta, sine theta. All right. So the coordinates of the point where the terminal sides of the angle intersect the unit circle are cosine theta, sine theta. The reference triangle has the length of the absolute value, because this is a length, cosine of theta, and the absolute value of sine of theta for the height. So this is an absolute value because it's a length, and this is an absolute value because it's a length. Note that the absolute value signs, the coordinates of sine theta and cosine theta, might be positive or negative, but the lengths of the sides of the triangle are always positive. All right, so what we do know here is we know cosine of theta. So I'm going to fill that in here. So cosine of theta is -3/5. What we don't know here is sine of theta. So the hypotenuse of the reference triangle has a length of 1. We do know that this is a length of 1. So basically we could use a Pythagorean identity of sine squared theta plus cosine squared theta equals 1. And by the way we write sine theta squared is typically written as sine squared theta. So instead of having the parentheses with the square outside, it's usually added right after the sign. Again, this is one of those nuances to the math language that we will see here. So when I'm looking at this one, this is really x squared, sorry, let me go back. Y squared plus x squared equals 1. So in our case, we don't know what y is. Y is our mystery. And so we're looking at my x squared. So y squared plus my x squared, negative 3/5 squared, which is going to be the cosine squared equals 1. This right here is y squared plus 9/25 equals 1. Subtract 9/25. This is become 25/25, so 9 minus 25 is going to be 16. 16/25. And that's squared. You take the square root. Again, we're talking about lengths, but we're going to put a plus or minus here just to note that, because again, we are in the third quadrant. We need to find sine theta in the third quadrant. Sine in the third quadrant is actually negative, while the length is an absolute value, is a positive. So this is 4/5. We're in the third quadrant, so this is going to be negative. All right, so we have found sine of theta using cosine of theta and the angle. Lots of work. What you really are doing is drawing a triangle using Pythagorean's theorem just to find the missing leg, knowing that this leg right here is 1. So that's primarily what this whole example is doing, and that's all. So again, if you have any questions or comments, always feel free to ask, and I'll catch you in the next video.